Hey YouTube, in this video we're going to be kind of reviewing a few techniques here when we convert from trig form to standard form and standard form to trig form in complex numbers, as well as operating with complex numbers in trig form, that is finding their products in or quotients, pardon me. So this first one right here, I just want to kind of review how we write the trig form of a number in the first place. This is currently in what we call standard form, that is we have some real part plus some imaginary part. And our goal here is to get it in this RCIS theta form where it tells us both the length it is from the origin, the distance it is from the origin, and the direction that it's heading in, okay? So 2 plus 2i, I think that the first thing we ought to do is sketch a picture of the situation. We have something that is 2 units to the right and 2 up in the complex number plane, and we say that this is the complex number 2 plus 2i. So we need to find just two values here to write this in trig form. We just need to know what r and theta are. So knowing that we can form a right triangle out of this, where its components are 2 and 2, we could say that two things are apparent. One is that we could find r using the Pythagorean theorem. So we get component squared plus component squared, the square root of that, so we get the square root of 8, which is 2 root 2. And in this case, if we want to find the direction angle, recall that the direction angle starts at the positive x-axis and rotates counterclockwise until it gets to this distance r. But we'd say that this theta right here could be found by doing the tangent inverse of b over a, or the imaginary part over the real part here, or opposite over adjacent. So we get tangent inverse of 2 over 2, which, by the way, tangent inverse of 1 is 45 degrees. So we would say that this number in trig form can be just written thusly. We would say that z equals 2 plus 2i, and in standard form is the same thing as something being 2 root 2 from the origin, and we have cosine I sine of 45 degrees, which these would tell us the same point in complex number space. Okay. So on this one here, we're going to write from trig form into standard form. This one's a little bit easier because we have some a plus bi part. It's just that we need to go ahead and, I guess, distribute this back through again. So when we distribute this back through again, we get 5 cosine of 135. I'm just going to say we get 5 times the cosine of 135, which, by the way, we should probably sketch this number first. It says that we're going in a 135 degree direction, so this is my direction angle here. And we are going 5 units out from the origin in that direction. So we're going to just say that this right here is this number here, 5 CIS 135. What we want to do is we want to go back and solve for the x and y components of this. So the x component is this 5 cosine 135, and what I know is this has a 45 degree reference angle on it. So since it has a 45, this is going to be root 2 over 2, and it'll be a negative root 2 over 2 just because it terminated in the second quadrant, and only sine values are positive in the second quadrant. We just evaluated a cosine. So we have 5 times negative root 2 over 2, and this will be plus now 5 times the sine, which is root 2 over 2, but it's a positive root 2 over 2, and we get that with an I at the end. So we say our number in standard form, keeping it exact, would be negative 5 root 2 over 2 plus 5 root 2 over 2i. So our a plus bi here, these are easily converted into decimals with the calculator, but these would be the x and y components, and you'll notice that x is negative, in this case negative, and that the y component is positive in this particular instance here. Alright, so last but not least, we have a couple of complex numbers here written in trig form where we on each of them, we know their r measurements, their distance from the origin, and we know the directions that they're heading in, their theta, so like theta 1, theta 2, okay? So the idea here is simply this. When we say take z times w, where these are both complex numbers, we are going to multiply their numbers in front, or their modulus values, so we get 2 times 4 is 8, and then we get cosine I sine of the sum of these two angles, which in this case is 160 degrees. We could also write this out. We could say cosine 160 plus I sine 160, just to kind of refresh our memories. As well as we could also, with something like this, interpret it as, I guess not interpret it, but if this were something that were over 360 degrees, you would just write it as an angle instead between 0 and 360, because you'd have another angle between there and there that would terminate in the same place as an angle that was over 360. Okay, so z times w, we want to do z divided by w now. So I'm just going to go ahead and write this out. We have 4 CIS 40 degrees, and this is over now 2 CIS 120 degrees, which were our two complex numbers from up here. In this case, we are going to divide their numbers in front, and then it'll be CIS, the top angle minus the bottom angle. We're going to subtract our arguments. So we get 2 CIS, and this would be a negative 80 degrees, which means if we were to sketch this out, we would say that we are going 2 units in a negative 80 degree direction, where this would be our direction angle right here, theta. It's negative 80. and we would just say, look, right there, that's a distance of 2. We could say that arbitrarily. But yeah, good to know how to convert from one to the other form, as well as find products and quotients using trig form. Cheers.